thing. So I'm going to go through some of the content that we're learning in Module 1. And at any point, even if you have questions, feel free to just type them in the chat box and I will be happy to answer them. Okay, so Module 1, we're talking about different types of data, and it covers sections 1.1 through 1.4 of the textbook. So we're going to start with just a couple of definitions. Um, Statistics is basically anything that has to do with data. We're going to talk about how we collect data. Once you've collected the data, how you organize it, you summarize it, and then how you can analyze that data in order to draw conclusions and inferences. So a lot of stuff having to do with data. And there's two different kind of groups that we can collect data from. We can collect uh, data from a population, which is the entire group that you're trying to study. So some keywords are like every, each, all, or a sample, which is a subset or a smaller group of the population. Um, Now, a parameter is a numeric. By the way, you guys can see the slides, right? Sorry, I just wanted to double check before I went too far. A parameter is a numerical summary of a population. So for example, if we're talking about an average, let's say average height. If we actually took every single person in the United States, let's say, and we found all their heights and we took the average, that would be a parameter because you're measuring the entire population. Whereas a statistic is a numerical summary of a sample. So the word statistic is a little bit different than statistics, right? So you can see here we have the definition of statistics, which is kind of this big, broad category, and a statistic, which is something very specific. It's a numerical summary of a sample. So a statistic would be like if we just took a group of people and we averaged their heights and we said, okay, well, we're going to kind of use this to make some assumptions about, the general population. Um, so a nice little mnemonic that you can remember is that population and parameter both start with P, and sample and statistic both start with S. Okay, so you can kind of remember how those go together. So let's look at some examples of how that works. Determine whether the underlined value is a parameter or a statistic. In a national survey on substance abuse, 66.4% of respondents who were full-time college students aged 18 to 22 reported using alcohol within the past month. So is this value a parameter or a statistic? So you can go ahead and type in what you think. Any thoughts? Right, so is this 66.4%? Is it measuring the entire population or is it just measuring a small sample of the population? Yeah, good. It's a statistic. Okay, so it's, all right, so that's exactly. So, right. So the value is a statistic because the respondents are a sample. The whole population is every single college student aged 18 to 22, but not every single college student aged 18 to 22 responded. So we're using this sample to kind of infer what's going on with the whole population, but we didn't actually measure the entire population. Okay. So now we'll talk about different types of variables, different types of data. The first thing that we're going to be looking at is qualitative data versus quantitative data. So qualitative variables are, it says classification of individuals based on some attribute or characteristic. Okay, so it's a little bit easier to kind of think about what quantitative is and then kind of say that qualitative is everything else. But you can remember qualitative is just kind of different characteristics. Whereas quantitative, right, think of the word quantity. Quantity is a number. Quantitative variables provide a numerical measure of individuals. So something kind of numerical with a number that has meaning. So I'm going to put a warning up here. Just because something has a number in it does not make it quantitative. The number has to have numerical meaning. Okay, so we're going to see some examples of what I mean by this warning. Okay, because there are things that have numbers in them, but the number doesn't actually have meaning. And actually, let me just peek it. Okay, so we'll go to this example. Okay, so for each of these, we want to determine whether the variable is qualitative or quantitative. Remember, quantitative means a numerical meaning. So the number of flights leaving an airport each year. Is this qualitative or quantitative? Good. Okay, because that's a number, right? We can say there are, 100 flights or 1,000 flights, and that number has meaning. It kind of represents the number, the number of flights. Okay, so that's quantitative. How about favorite sport? Good, good, qualitative. Okay, so that one does not have any numerical meaning. It's just some sort of category. How about age? Good. Um, was that, I didn't know if that was from the last one. So age is going to be quantitative, right? So you guys are saying qualitative. Age is quantitative because it's a number, and the number has meaning. It refers to how many years it's been since you've there's a car alarm going off. It refers to how many years it's been since you were born, and that number you can kind of do arithmetic even with that number. You can say I'm twice as old as I was before. So there's definitely some sort of kind of numerical meaning to your age. Now, how about your telephone number? So this one's a little bit trickier. Yeah. So your telephone number is qualitative even though it's a number, right? So this is kind of one of those trick questions because it's a number, but that number doesn't really have meaning, right? If you have, some 10-digit telephone number, right, that doesn't really represent, some, 10, 22 million, whatever your telephone number is. That doesn't represent something as a number, even though it has numbers in it. So even though the telephone number has numbers, it's qualitative. And then how about Social Security? Right, same thing. Even though it has numbers in it, right, it doesn't have meaning as a numerical meaning. It just happens to have some numbers in it. Okay, so now we're going to look at the difference between discrete data and continuous data. So discrete data, we say are countable measures, and continuous data are non-countable measures. It's now technically, let me see what I wrote here. Okay, so technically continuous data, what you want to be looking at is can it take on any value in a given range? There are technically things, so here, let me pull this up. So when you see something and you want to know if it's discrete or continuous, this is what you want to ask yourself. You're basically saying like, can it be anything in between 3 and 4, or does it have to be either 3 or 4? So you want to say, is it possible for it to be 3.1? Can it be 3.01? Can it be 3.0001? Right? So if it's continuous, it can be any number between 3 and 4. So if your answer is yes, then it's continuous. If the answer is no, then it's discrete. So the slight technical point that I kind of got tripped up on a little bit was that if it could be 3 or 3.5 or 4, that's still discrete. Even if it can be 3.5, that doesn't stop it from being discrete. From like in order to be continuous, it needs to be able to take on any value you want it to be. So not just 3.5, but also 3.49999, right? So and it needs to be able to take on kind of any value. But in general, kind of the vast majority of time that we're in particular in this class, discrete data is going to be a whole number because you're going to be counting something. Okay, so let's look at these examples. Decide whether the random variable x is discrete or continuous. Okay, so our first example is that x represents the number of quarters needed in a parking meter. Is that discrete or continuous? Yeah, good. Okay, you're not going to put in like 1.5 quarters. You need 1 quarter or 2 quarters, but nothing in between. Okay, how about the height above the ground when skydiving? Okay, excellent, right? Because you could be, 3 meters up. Well, that would not be very good for skydiving. I don't know the right height, but 3,000 feet or 3,000.1 or 3,000.01, right? Kind of any height, it's possible for it to happen. So that's continuous. Okay, the time needed when taking an exam. Good, continuous, right? Because you could take, 45 minutes, or you could take 45 minutes in 1 second, or you can take 45 minutes in half a second, right? Any kind of time is not specifically accountable. Okay, and how about the number of movie tickets needed for a family to see the movies? All right, you guys are awesome. Discrete. Perfect. Okay, so now levels of measurement. This is the table that's in your book, and it gives you kind of all sorts of information about what these levels of measurement are. I like to kind of go through and ask myself, so I'm going to kind of, this is the table that's in your book, but I'm going to kind of skip this and go to a series of questions that you can ask yourself in terms of figuring out the level of measurement of a variable. So basically, well, let me just go back to this. Basically, the idea of level of measurement, it allows you to know what you can do with your variable. Whether, you can then say, oh, you know what, I can add these numbers. And it also can kind of help you, once we look at graphing, certain types of variables can be graphed in certain ways. But other than that, I'm going to kind of skip this chart and kind of go to these questions to ask yourself. The first thing you want to do is say, can you put the categories in a natural order? If the answer is no, then the variable is nominal. If the answer is yes, then we want to move on to the next question. Okay, so the idea of a natural order, so let's say I'm asking you to rank a TV show, and the choices are poor, good, very good, or excellent, right? Those kind of have a natural order. You wouldn't say poor, then excellent, then very good, then good, right? That would kind of be out of order. So that's what I mean by a natural order. Whereas if I said, what's your favorite sport out of football, baseball, soccer, and hockey, right? I could just as easily have said, what's your favorite sport out of hockey, soccer, baseball, and football, right? There's no natural order to those answers, okay? So that's what I mean by, is there a natural order? So that's the first question you want to ask yourselves. Is there a natural order? Okay? If there is, then we'll move on to the next question. So now we want to say, do differences in values have meaning? Okay, so remember, what does difference mean? Difference means subtract. If no, then the variable is ordinal. If yes, then we'll move on to the next question. Okay, so as an example here, I'm going to give you two kind of very similar examples so you can see the difference. In both examples, we'll talk about a survey where we ask people about how much education they have. In the first survey, we ask them, do you have some high school graduate, some college graduate, some graduate work? Okay, so first of all, those do have a natural order, okay, because it's kind of increasing the amount of schooling they have. But you can't really subtract that. You can't say, oh, some college minus some high school equals, right? That doesn't really make sense. So the differences, the subtraction doesn't have, oh, did I lose you? I didn't lose you, right? Okay. The subtraction doesn't have meaning. But on the other hand, if we are saying how many years of education post high school do you have, and Joe says I have 2 years post high school, and Sean says I have 6 years post high school, well then I could subtract that, and I could say, okay, 6 minus 2. Therefore, Sean has 4 more years than Joe does of post high school education, right? So that subtraction, that difference, has a meaning. Okay, so then if the differences have meaning, then we're going to, what was I'm just seeing you saying no. I don't know what that was a response to, because I just noticed that. I probably said, does that make sense? And you said no, and I don't know what didn't make sense. Oh, fine. I unplugged my computer and my screen turned off for a second. Okay, so then we ask ourselves, does the number 0 mean nothing? Okay, if it means nothing, sorry, if the answer is no, so 0 doesn't mean nothing, then the variable is interval. And if the answer is yes, then the variable is ratio. Okay, so there's a couple of classic examples for interval. So let's say your variable measures the temperature. Okay, it measured in Fahrenheit. If it's 0 degrees Fahrenheit, that doesn't mean that there's no heat, right? That doesn't mean that there's just nothing there. There's no temperature. It just means that it's 0 degrees. It's kind of almost randomly assigned where 0 is, because 0 Fahrenheit is different than 0 Celsius. So 0 in that case doesn't really mean nothing. But if the variable is how many donuts did I have today, and the answer is 0, that really means nothing. I didn't have any donuts. Okay, so if that's the case, then the variable is ratio. Okay, so let's look at some examples, and we'll keep going back to that slide just to kind of work our way through. So, nation of origin. Okay, so let's look. Nation of origin. Can you put the categories in a natural order? Right, so the different categories in nation of origin would be, United States, Canada, Mexico, Jordan, Israel, Syria. Is there kind of a natural order that all of these different nations fall into? No. No. Good. Okay, so the answer is no. So therefore, nation of origin is a nominal variable. Okay, so basically there's not much that you can do mathematically with nation of origin, right? You can't add, like, there's really, all you can do is say this is this category, this is this category, that's that category. Okay, volume of water used by a household per day. Okay, well, can you put the categories in a natural order? Okay, so 4 gallons, 5 gallons, 6 gallons. Yes. Okay, so let's move on to the next question. Do differences in values have meaning? Right? If one family uses, 100 gallons and the next family uses 200 gallons, can I subtract those and actually say something about that difference? Yes. Excellent. So let's move on. Does the number 0 mean nothing? Amount of water used. All right. Excellent. So yeah, so here the number 0 does mean nothing, because if you have used 0 gallons, that means you didn't use any water. Okay. So in this case, 0 does mean nothing, right? Because it's just no water is being used. So therefore, we have a level of the variable is at the ratio level of measurement, because we answered yes to all of the questions. So that's ratio. Okay, so this is kind of the example I was giving before. The highest degree conferred. So let's go back to our questions. Can you put these categories in a natural order? Yeah. Excellent. Okay, let's move on. Do differences in values have meaning? The highest degree conferred. Excellent, right? You can't take like a master's degree and subtract a bachelor's degree. That doesn't really make any sense. Okay, so since the answer is no, then the variable is ordinal. Okay, so we have an ordinal variable. Okay, how about eye color? I'll let you go through these questions. For eye color, I'll let you kind of go through these on your own and tell me what you think the variable is. Good, right? Because the variable is nominal, because you can't even put these in a natural order. Okay, and how about the year? So I'll let you go through these and kind of tell me what level of measurement you think the year is. Good, excellent. All right, you guys got it. Okay, so it's interval. Okay, so the next thing we're going to talk about, just very briefly, is an observational study versus an experiment. So with an observational study, the person conducting the study is not allowed to interfere at all, okay? It's as if you're just like a ghost in the room, right? You're not making any changes. You're just observing what's happening and you're collecting data in their natural environment. So often surveys are observational studies because you're just kind of asking people about things that they've already done. You're not having any impact in what they're doing. Whereas an experiment, you're intentionally interfering. Usually you have some sort of control group and experimental group. So let's say you wanted to know if a certain brand of juice was better than another brand of juice. In an observational study, you can just kind of like the people will just kind of drink the juice on their own, and some of them will pick one, and some of them will pick the other, and then you just kind of observe what they pick. With an experiment, you would actually like give one group juice A, and another group you'd give juice B, and then you'd compare, how they rated it. So you'd actively be kind of breaking people up into groups and choosing for them what kind of juice they're having, as opposed to just kind of letting them do their natural thing and then collecting the data about what happens. Or you can still ask them questions about it, but you're not you don't have no impact on what they did before you took that survey. So a designed experiment is the only thing that allows a researcher to claim causation between two variables, an explanatory variable and a response variable. Okay, so if you're doing an observational study, if you do a survey, you can say that there's a high correlation, and in module 4, we're going to talk a lot about what correlation is, but you can say like people who did A were much more likely to do B, right? There's a correlation, but you can't actually say that A caused them to do B if you have an observational study. Only a designed experiment allows you to actually say this caused that, with any degree of certainty, obviously. Okay. Any questions before I move on? You don't have to wait for me to ask for questions. If you do have questions, just type them in. But I figured I would pause here. Okay. So now let's talk about different types of samples. Here are the different types of samples. I'm going to go through these definitions, and then I'm going to kind of give an example of all of them that kind of all works together. So a systematic sample is obtained by selecting every nth individual from the population, meaning every third individual, every fourth individual, every fifth individual. This is often done if there's like a factory with like something coming off an assembly line, and you want to like grab every 10th object to kind of make sure that it's okay. So that would be kind of a systematic sample. So it's kind of, every other one or every third one, that's systematic. A cluster sample, and by the way, right, just to kind of, before I kind of started talking about the types of samples, but I just wanted to remind you, a sample, right, is a small collection of people within the population. So if you want to study the whole population, if you want to get a sense of like something about, everyone in the population, but it's not realistic to actually survey every single person in the population, then you're going to want a sample of the population. And these are different ways to kind of create that sample. Okay, so a cluster sample is obtained by selecting all individuals within a randomly selected collection or group of individuals within a randomly selected collection or group of individuals, usually based on location. And you'll see in our example, basically the idea is that sometimes it's much easier to get people who are close together as opposed to, so a cluster, you would basically say, okay, I'm gonna take this little group and I'm gonna take another little group that's kind of farther away. And I think those will become clear when we go to our examples. A convenient sample, so I'm just gonna kind of move on and you'll see the example. A convenient sample is a sample in which the individuals are easily obtained and not based on randomness. Okay, so you always want to be very wary of convenient samples. Okay, if they're basically not making any effort to make sure that their sample is either random or has some degree of randomness, and also well represents the population. If they're just saying, okay, anyone who happens to be come to me, you really want to be wary of that. You can't necessarily use that to make very good claims. A stratified sample is when you want to group students based on common characteristics called the strata, such as age, marital status, ethnicity, etc. And you basically want to make sure that you have kind of each strata well represented. Okay. And then a simple random sample is that it's simple random if every sample of a given size has the same chance of being selected. So this is basically like just pulling names out of a hat. Okay. So I know that this was a lot of information just kind of thrown at you all at once. But let me pull up this example and I think it'll clarify things a little bit. So in this case, our population is going to be all of the current Math 130 students. Okay, so there's about 700 of you. Okay, so what would a systematic, so these are all different ways of creating a sample from these 700 students if it's unrealistic to actually get all 700 of you. So a systematic sample I could do by taking all 700 students, putting you in alphabetical order, and choose every sixth student on the list. Okay, so that'll give me a sample, right? I won't have all 700 students. And it'll be, somewhat random. Not like, if I choose, it's not like I'm more likely to have students from one section or another section. But I kind of just go through and I choose every sixth student on the list. So that's systematic. I changed the order. Okay. A simple random sample would be if I put all 700 names in the hat, and let's say I want a sample of 20 people. So let's say I would just draw 20 names out randomly. And I say, or you can do this virtually. And we'll talk about that in a minute, how you can essentially virtually pull names out of a hat to get a simple random sample. So cluster and stratified, people have get confused these two. So I think hopefully this example will clarify what the difference between the cluster and the stratified is. So in a cluster sample, you would randomly choose 4 sections of Math 130. I think there's like 15 sections or something like that. So you would randomly choose 4 sections of Math 130 and select all of the students in those sections. Okay, so you would do this, right? Remember we said cluster is kind of often based on location because it's kind of easy to kind of get a whole bunch of people who are near each other. So this would be like if when we collected our sample, we wanted to do it so that the instructors of those 4 sections, they can easily say, send out an announcement to all of their students. So it's kind of easy. So this way we don't have all of the Math 130 students. We just have the students from 4 sections. But because those 4 sections were randomly chosen, there's basically still a degree of randomness to our sample. And in some ways this is easier because we can kind of have those 4 instructors just kind of work with all of their students. Whereas a stratified sample we would use if let's say we wanted to survey all of the Math 130 students about certain aspects of the course, and we really wanted to make sure that people from every single section were represented because different instructors might do things differently. So with a stratified sample, we would randomly choose 3 students from each section. So we would actively be making sure that every single section is represented, but there's still this degree of randomness, okay? Because we're going to take 3 from this one, 3 from this one, 3 from that one. So notice that neither the cluster nor the stratified are simple random, because with the cluster, it's kind of, in a simple random sample, it's possible that they all come from, 4 sections, but it's also possible that they're all spread out, or it's possible that, one section isn't represented. So a simple random sample is kind of the most random, but it's not necessarily the best given your situation. Okay, so depending on the situation, you might want, to use a different sample. And then a convenient sample would be everyone who is attending this webinar. And I would say that in general, a convenient sample is not a great way to choose a sample because you guys might not be representative of all the Math 130 students. You guys are probably more involved than the average Math 130 student because you're deciding that you want to come to an optional webinar. So that would be a convenient sample, but it's very convenient for me because you're all right here. I can just pull you. Okay. So that's those are the different types of samples. So now we're really going to talk more about these simple random samples. because I mentioned, doing this virtually. If you don't actually want to write out all 700 names and put them in a hat, and actually start pulling names out, how can we find simple random samples, which is essentially doing the same thing, a little bit more easily? Oh, I forgot I had do you guys want to do this example or do you want to move on? Okay, no answer, so we'll go ahead and do this example. Okay, so a radio station asks its listeners to call in their opinion regarding the use of U.S. forces in peacekeeping missions. What kind of sample does the radio station end up getting? Yeah, a convenience sample, right? Whoever ends up calling in, it's easy, it's convenient for the radio station, but it's not necessarily that great of a sample because people who have stronger opinions are more likely to call in. Okay, I see you typing. I'm going to go on, but I'm keeping my eye on you. On the typing. Yeah, exactly. So, college official divides the student population into 5 classes: freshman, sophomore, junior, senior, and graduate. The official takes a simple random sample from each class and asks the members' opinions regarding student services. What kind of sample is this? Exactly, stratified, because you're really making sure that you have people from each of the, in this case, strata, right? The strata are the different classes. So you're making sure you have freshmen, sophomore, juniors, seniors, and graduates all in your sample. Oh, okay. So here are your answers. Okay, so simple random samples and random number tables. Okay, so I said, while choosing names out of a hat is nice in theory, if you have a large population, you don't want to actually have to write out every name and put it in a hat. So we can do this virtually by assigning a different number to each member of the population and then randomly choosing numbers. The numbers that we choose indicate which members of the population are in the sample. So let's just do a very basic example. If here's my population: Michigan, New Jersey, Washington, Arkansas, Texas, and Idaho, and I want a sample of size 1. I just want to choose one of these 6 states. If I roll a die and it lands on a 5, I have just selected Texas to be my sample. Okay, so this is just to show you how you can assign numbers to members of the population, and then when you choose a number, you're essentially choosing a member of the population. Okay, so that's pretty basic. This is actually called a frame, by the way. When we assign numbers to the members of the population, you're creating a frame. Okay, but what if the size of my population is more than 6 and I want a sample of size more than 1? Then this rolling a die might not work particularly well. Okay, so now let's take our, so that's when these random number tables come in. Now, we use random number tables in the textbook and in your homework. I'll actually say right now, they're a little outdated. Now people generally just use these random number generators, which you can even find them online. That'll just kind of choose random numbers for you. But the way that the textbook uses it and the way the homework uses it, they use these random number tables. Okay, so how's this going to work? The random number table basically just gives you a bunch of numbers. And okay, and so remember, we still have, Michigan assigned to the number 1, New Jersey assigned to the number 2, etc. So now we want a simple random sample of size 4. So meaning we want to choose 4 of these 6 states randomly, and we want to use this random number table. So what we're going to do is we're going to go through the numbers starting from 4, then 7, then 0, then 6, then 8, etc. And we're going to see if we can add something to our sample. So let's start by looking at that 4. Okay, what does 4 do in terms of, well, so I'll start with that first one. So 4 is first, so that means we're going to put Arkansas into our sample. So now we move on to that 7, okay? Does 7 correspond to any of our states? No, so we just skip it, okay? How about 0? Okay, so we just skip 0. All right, how about 6? Okay, all right, good. So let's put Idaho in our sample. How about 8? All right, all right, we'll move on. All right, how about 5? Okay, let's put Texas in our sample. All right, now we get to 4. What do we do with that 4? Any ideas? Right. So 4 represents Arkansas, but we already chose Arkansas. Arkansas can't be in our sample more than once because we want to have actually 4 different states. And if we choose Arkansas, we were only choosing 3. We've already have Arkansas, so we could just move on. So 4, we move on again. So now 3. So what happens with 3? Exactly. So now we have Washington. So now we've just used this random number table to pick 4 states. Okay. So now let's say we have, so this was easy because we only had fewer than 10 objects. So each thing was only assigned a 1-digit number. But now let's say we're the president of the student government and you want to conduct a survey to determine the student body's opinion regarding student services. The administration provides you with a list of names and phone numbers of the 485 registered students. We want to choose 5 of the 485 registered students. And here is the random number table that we're given. Okay, so the first thing that we're going to do is we're going to look for 5 3-digit numbers between 1 and 485. And so you can see what I did here is I put this red line so that even though the random number table is kind of written in chunks of 5 digits, I put the red line so that I can really only pay attention to the first 3 digits. So just like before, we were only looking for a 1-digit number, so I only had to pay attention to the first digit. Here I'm looking for a 3-digit number, so I want to pay attention to the first 3 digits, okay? And so just like before, if I had something that was 7 or more, I just skipped it. Here, if I have something that's more than 485, I'm just going to skip it. So what's the first number that I'm going to choose? Exactly, 98. So let's highlight that. Then what? All right, good. Now what? 181, awesome. What's next? Okay, good. And did I do 5? 1, 2, 3, no, one more? Okay, and there you go. Those are going to be the 5 of the 5 students that we need of the 485. Okay, now I'm going to do another similar example. Now we want to obtain let's see, sample of 6 students out of 378. Okay, so we don't want anything above 378. And the reason this is different is that we have to go on to the second column. And there's actually more than one way to do this, to use a random number table. And you're going to end up getting a different simple random sample, but both of them are okay. So some people, sometimes, let me see if I can get an arrow. Let's just start and then I'll kind of tell you okay. Let's just start and then once we get to the bottom of the column, then I'll kind of tell you the different options. Okay, so what's the first thing between the first 3-digit number less than 378? Okay, good. Still 98. Oops. Okay. And now what? Okay. Next. Cool. Next. Okay. Okay, so now we've picked 4. Okay. And we need 6. So the way that I'm doing this is I'm just going over to the second column. The way some people will do it is, how come I can't move this arrow? Is they'll basically start looking, oh, this arrow is not really working for me. Can I draw? Here we go. They'll basically, this is really horrible. They'll basically look at these 3-digit numbers. So basically they're moving the red line over 1 to the right, but they're also kind of moving the kind of start line over 1 to the right. This is the way I like to do it. And in terms of your homework, I'm actually pretty sure that you actually don't even ever have to go to the second column. But this is the way I like to just kind of hop over to the second column. And as I said, both of these are kind of correct ways of obtaining a simple random sample, but they will end up giving you different simple random samples. Okay, but this is a perfectly valid way to do it. So this is how I'm going to show you how to do it. Okay, so I'm going to show you just kind of going to that next column. Oops, what happened? Okay, so that your next number is just 008, and then your next number is just 219. Okay. Okay, you guys seem to get what's going on. I threw in one more example. Let me just get rid of this arrow. Ooh. I threw in one more example. Really the only difference here is that now we're looking at, because there are 3,147 students. There, right now we're looking at 4-digit numbers. So really the only difference here is that I put the red line four digits over, so that we're looking at 4-digit numbers. So what are the so I'll let you guys do this. So what are the first four-digit numbers that are between 1 and 3,147? Keep going. Okay. So you guys got this. You guys got this. You seem good. Um, so I'm here. I've got some more time if you guys have any questions about anything that came up. But this is all I prepared for you. So. Um, 1220. Let me just look let me try to see where the 1220 is. I don't see a 12, I'm sorry, I'm just looking for that 1220. The next line right after the red line. Um, the next line right after the red line. The number 1 and then the number 120. Oh, so yeah, got it. So it would be 1120. Got it. No, that's fine. That's why I couldn't find it. No, so well, we only needed four numbers, so we got all four of them. Um, so that would be another method. So that would be kind of actually another possible method of using this random number table to collect a simple random sample. If you're consistent, that would work also. Meaning if you always kind of use the red line the same way, um, then you're gonna get a simple random sample. It would be a different simple random sample, but the key is really to always kind of use the same method of using the random number table. Um, and the truth is, honestly, as I said, in your homework, and I don't even think you have one of these on the exam. You're not even going to have to go past the first column. And in real life, as I said, these are really pretty outdated, and everyone uses, a computer-based random number generator. So I wouldn't worry too much about these problems. It is the problem that people are most likely to get wrong in this section. But from a practical point of view, it's not really that important what method you use for going to the second column, just because really everyone uses random number generators. Of course. Anyone else have questions? Okay. If not, I'm going to at least stop the recording. Okay.